It's like they're popping the screen. It always makes it. Coach Jay, what's up? How we doing? This is session number 2. And we got Robbie, Tony in the house. Even Trevor's in the house today. This is good times. I was telling him I always like to come on the screen because it's like the starting lineup, you know? I don't know why. It's just kind of weird. But we're going to get this rolling today, and we're going to answer some questions, talk a little statistics. This is the second of 2 study sessions that we are doing. We'll also have one later today at Panera. So show up, show out if you have any questions there, and we'll go from there. As far as the questions go, all the questions, in fact, I want to show you real quick, all the questions that we're going to do are straight off of the practice multiple choice at the very bottom of this topics page, of the final exam topics page. I told the guys that are here that this would be a really good idea to kind of start with in terms of maybe having a practice exam. So if you get the opportunity, go through this. Man, I think it would be a really, really good idea there, okay? So with that being said, we're going to get started on this specific one. What might happen as we go through is, you know, we may have different concepts we'll talk about, or just maybe specific questions, but we'll start at it and then go from there, okay? So first one we're going to start with is number 2. Okay, so we're going to start there, and then we'll go forward. So we're going to go to number 2 first. So I'm going to get my flip chart here rolling. Okay. All right, here's problem 2. Now, as we go through some of these, the wording of these are very, very important. What are they asking? Breaking it down. The hardest thing I think with AP statistics is seeing what are they asking me, right? What are they asking me on that? So as we look at this, it says below is a two-way table summarizing the number of cylinders in selected car models manufactured in 6 different countries in the 1990s. Okay, it says use scenario 1.2 to find out which of the following is a marginal distribution. Okay, what does marginal distribution mean?
I can't remember that. Yeah,
What's conditional distribution?
it's like
conditional means that there's a condition on it, right?
Yeah.
If this, then this, right? When we talk about marginal distribution, I'm pulling up the official definitions so that you kind of have it at home and here as well. Marginal distribution says that the marginal distribution of a subset of a collection of random variables is the probability distribution of the variables contained in the subset. It gives the probabilities of various values of the variables in a subset without references to the values of the other variables. That sounds like a bunch of mess. So really it's the opposite, or it doesn't have a condition on it, right? So let's look at each of these, and if we were on the test, what would we do with that, right? What would we do with it? So it says the percentage of all 4-cylinder cars manufactured in Germany, right? So the number of cylinders, if I were to do that, right, wouldn't we put and I'll actually use my pen on this, we were finding the percentage of all 4-cylinder cars manufactured, right? Wouldn't we put that probability like right down here? Wouldn't that be where we put them, right? So we would do 19 of 38, and then this whole thing should add up to be equal to 1, right? Next is the number of 4-cylinder cars manufactured in Germany, right? Well, number is different than percentage, right? We'll come back to that. Number would be right here, the total, right? All right, the next one says the percentage of all cars manufactured in each country, right? Percentage of all cars would be over here on this side. Percentage of all cars manufactured in each country. Yeah, that would be here, right? Percentage of all cars. Yeah, okay, this is all cars. So this would be over here on this side, right? And here. Number 4 says the percentage of cars manufactured in Germany for each cylinder, or for each number of cylinders. So really what that would be is the percentage of here, 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 and here, right?
Separated into 4.
Separated into 4. Good. And E is the number of cylinders for 4, 5, 6, and 8. So
Wouldn't that be the total?
that would be, I think that would be here, wouldn't it?
That's right. That's
Right
19, 1, 2, 8.
19, 1, 10, 8. And then, so when we talk about, I think I messed up B. B was the number of 4-cylinder cars manufactured in Germany. So that means the number would be here. The percentage would be the percentage of cars manufactured in Germany for each number of cylinders. So the question is which is different? What would be a marginal distribution?
There's no condition.
There's no condition on it, right? If this, then this. So which would have no condition on it?
E.
Say that again.
E.
I would say yeah, the number of cylinders, 4, 5, 6, and 8. Let's check it out. Let's make sure. Watch us be wrong. First problem, man. This is live, man. We don't even, when we're going for it. The answer is actually C. Why? The percentage of all cars manufactured in each country.
Wouldn't each country be a condition?
Let me do this. Let me look over here. I'm confused on this one. All of them sound like they're the same thing.
Yeah.
The definition I found online I didn't really like, because that kind of more or less confused me from what I had originally thought there.
Teachers and students at this time, all students taking a world language or conflict exam should be in the exam room. Teachers, if anyone is missing, of course, email them to Osgood, and we will check up on those students and get them where they're supposed to be. All other students at this time should be either in the media center or off campus and not hearing my voice. So if you do hear my voice, that means you need to be in the media center.
Except
So
here.
please do that,
AP stats could be here.
and that would make me happy, right? Happy. All right, students, it's time to begin our second exam. I wish you all the best of luck. As you finish, please stay in the room and stay quiet. We will come back on in about 90 to 95 minutes from now to dismiss you, so probably around 11:55, to do some final announcements and dismiss you from the day. Okay, again, teachers, email me any students email Ms. Osgood any student who is missing, and students, good luck on your exam.
Okay, so basically, and this was in statistics when we talk about marginal. What's up, y'all? What's up, team? Got Johnny and Julie in the house. We just got stumped on our first one, so this is a good start to our review, right? It's actually, so with the marginal, this is where the definition I said here was a little bit off. The marginal can be one of two places. It can either be, make sure I got here, okay? It can either be the percentage over here or the percentage over here, okay? But that should make sense because both of those do not have a condition on it. For instance, the condition with Germany is the fact that we're focused just on Germany, right? That's the condition that's met. When we talk about a condition, yeah, it seems as though C says the manufactured in each country, but really that's just the total that's there. It doesn't mean that the cylinder, like if I said, what percentage of the number of cylinders are in Germany, now I'm focused on one thing, that would be our conditional. That's there, okay? So with our marginal, we can think total on either the right or bottom side. Here's the one thing with marginal, it's always with categorical, a categorical variable, okay? So yes, these down here, 1, 2, 3, and 4, we think about that, but remember we're talking number of cylinders, right? That would be more what, quantitative, right?
Okay.
Categorical, the country, that's what we'd be focusing on. So we would say that the marginal is the distribution of the categorical variable that's there. So it's either on the bottom or right side, depending on how the two-way table is set up. Okay? Does that make a little bit better sense on that?
Yeah.
So that's what we're talking about with that there. Okay? It's been so long on that one. Really haven't brought that one back up, but that's how we get to that answer. Correct? We're doing the bottom, y'all, of the practice test. So if you all have any questions, we'll just continue and go from there. Do you want to just keep going to the next one?
Sure.
All right, let's go to.
Using the same scenarios.
Oh, is it?
Yeah.
Cool. Scenario 1.2. All right, let's see what we got on this one. We're going to go right straight above it. Now, this is question number 3, just a heads up here. Question number 3 here says this. From this table, we might conclude that the following. Well, once they say that, I like to do cross-elimination a little bit, okay? A, there's a strong association between country of origin and number of cylinders, okay? Well, is that true? Maybe. I heard yes and no. Can we come back to that one? Come back. B says about 18% of the cars sold in the United States were manufactured in Japan. Does that have anything to do with the problem? Am I wrong? Do y'all see something I don't? I don't think that has. We haven't mentioned U.S. and you know what I'm saying? U.S. and Japan in that way. 18% of the cars sold in. Now these are the amount manufactured in 6 different countries, right? This has nothing to do with selling anything. Yeah. So I would say B is out. C says these data or these pieces of data could be more effectively presented with a box plot. That'd be really hard, wouldn't it?
Yeah.
It'd be really hard because we'd be talking about min, Q1. There's not enough pieces of data to really represent that. So I would say that C would be false, right? Says D says the only 8-cylinder cars in this data set were manufactured in Germany.
False.
Yeah, because why?
In the USA.
US, right? E says all the cars on Italian roads have 4 cylinders. All the cars on Italian roads have 4 cylinders.
Can't assume that.
Can't assume it. Even though it's manufactured, right? The number of cylinders that were manufactured in these countries were here. That doesn't necessarily mean, right? We have cars from Japan and all over on our roads. So you can't assume there. By process of elimination, we would say A is true. Again, I can't say cause and effect here. But what we can say is there may be a strong association between the country that I have and the number of cylinders. So as I look at this, I would even say a number of cylinders manufactured, but I know I'm being picky. But as we look at that, there are some trends that we see here that we'll take into account. So there is a strong association that's there on that. Okay? Questions on that one? All right, right on. Let's go to another one. Y'all want to just keep going down? Cool. And if you all want to stop me, go right ahead, okay? So if you have one that you're like, Coach, could you do this one? We'll go through that one as well. But I'll see 4 and 5 right now, and then if we want to change that up later on, we absolutely can. All right, 4 and 5. Again, are some multiple choice here. I don't know if y'all like, I never like the ones that say like, which of the following statements is true, or which one, the worst one is, which one is not true. So you have to like go through them. But when I do that, I kind of like the process of elimination there. That's there. Which of the following statements is true? Let's start with A. In a distribution, that is skewed right. Okay, so this thing's skewed to the, sorry, get it backwards. Woo, skewed right, right? It says the median is larger than the mean. So this would say that the median's here and the mean would be here. Is that true?
No.
No, remember the mean follows the tail, right? It is not resistant to outliers. The median, though, is, right? Because it's the middle value. So we're going to cross off A. That's a huge concept for the exam, just a heads up. B says 50% of the scores in a distribution are between the first and third quartile. Is that true?
No.
Okay, let's look at it. Or actually, here's one right here. This is the, what percentage of the data is to the left of this?
25.
25, because what is the definition of Q1? 25th percentile, right? What's the median? Half, right? So that's 50%, and then this is 75%, right? So that seems to be true. If you really want to just check it, what I would do if I was on the actual test, AP or final, I would actually circle B, but I would circle 4 to just come back to it, just to double check. So we'll do our double check right now. It says this, C says the third quartile of a distribution is always greater than the mean. Is that true?
Not the median.
Correct, the median, but not the mean, right? Because if it was a, like in this case, right, these actually should be flip-flops. Could it be that there's so many outliers out here that, yes, Q3 may be there, but the mean still could be larger than that? That's true, right? Box plot does not have the mean on it, right? Can't find the mean unless it's given or they give us the data that's associated with it. So C's gone. D says the median of a distribution is always greater than the mean. The median of a distribution is always greater than the mean. That's a little tricky. Is that true?
No.
No, because we have symmetric. What is it? What's the mean equal to?
Median.
Median. It's exactly symmetric. So that one's gone. Go ahead.
If you see like the word always, it's usually like always wrong. For the most part.
Kind of countered what you just said right there.
Yeah,
But yes, yeah. If you see always, I don't want to say it's always wrong because then I'm kind of like, I don't know if that there's a little irony there. Sorry, that's really
That's
corny.
true.
But I would say that probably is one that you want to just kind of have a red light on. Just okay, is it or never, right? Now sometimes that is true, and we want to be careful on that. But that's something maybe have a red light on. Just kind of maybe put that in the back of my brain. And then E says the range of the distribution is typically smaller than the interquartile range. That's completely false, right? Because the range would be from here to here, where the IQR is from here to here. The range, I don't want to say always, right?
Yeah.
The range is going to be larger, though, than the IQR. And because the range is from the mean to the max. So that's all. And so that shows us that B is the correct answer. Okay? Let's go to number 5, okay? Different writers have different styles, okay? The lower parallel box plot is describing the distribution of word length. Sounds like Beyonce, right? Activity. That's there. And it says chapter 1 from the chapter 1 of statistics textbook. Hold up. Oh, okay. So this is from the statistics textbook, and these two are like novels, right? That's there. So what is it saying? Well, it says, based on these graphs, which of the following statements must be true? Couple observations. What does this dot mean?
Outlier.
Outlier. What's the definition of that outlier?
It's 5 times the IQR from Q3 to Q1.
And what's in the front of this? Q3 plus that, right? What would be this one over here, if there was one? Q1 minus 1.5 times IQR, right? So just a heads up, if you ever needed that, that's something you need to test on these problems. Okay. So those are some observations that we see. We see where the median is in the middle, and let's just see what they said. It says dot plots of the distributions of James's word length and Starnes' word length are identical. Are these two identical?
Pretty much.
Pretty daggum close, don't they?
Yeah.
I mean, unless my eyes are going, dot plots of the distribution of James. Okay, so here's the question. Are these dot plots?
No. That's tricky.
Do you see that?
Yeah.
That almost got me. So let's come back to A because I don't think that one's probably going to be. They tried to trick you there. Okay. B says that is me because I heard box plot in my head, but it's dot plot, a little different. The longest word in the distribution of Rawlings word lengths is shorter. Okay, so let's do that. The longest word lengths the longest word in the distribution of Rawlings word lengths is shorter than 25% of the words in the James distribution.
No.
That's incorrect, right? Because here's it's not even close. This is the larger one, right?
No.
And it says that it's shorter than 25. Shorter would be right in here, right? It was more to the left, but it's not. C is the range of Rawlings word lengths is smaller The range of, these are wordy. The range of Rawlings word length is smaller than the interquartile range of Starnes word length. Is this smaller than this?
No.
No, it's not. That's gone. D says the median word length for Rawling is longer than for either Starnes or James.
Yes. I thought it was the same for.
Here's the median, right?
Yes.
It's pretty close, but yeah, I would say that it is longer. I would say that this one, D, is true. See what E says. 75% of the words in Rawlings distribution, 75% would be from here on, right? Is longer than for either Starnes or James 75% of the words. That's incorrect, right? Because, okay, so let me read that again. The median word length for Rawling is longer. Median word length for Rawling. This is, let me erase this. We said it was D, right? 75% of the words in Rawlings distribution, so that's here, is longer, are longer than the median word length in Starnes' distribution.
When you say 75%, how do you know it's from Q1 past? Not
That's the definition of Q1, right? Does that make sense? Q1 means that's the 25th percentile. How do we get Q1? We take the median, right? And we take the beginning number, and we literally find the middle number between the first 50th percentile. That make sense?
I was just wondering because you're picking the top 75% and not the bottom.
Oh, you're right. 75% of the words in Rawlings distribution.
That'd be Q3, right?
That's right, Q3. That's why I was confused. That's why I got y'all. Are longer than the median word length in Starnes. So here's the median word length, right?
Isn't that right too?
75% of the words in Rawlings distribution are longer.
It's false.
Correct. That's false. Why?
I don't know. I just checked it. Because I was like.
Because it's D, right?
Throw me off, yeah.
It's D?
Yeah, because that's what I circled, but I was like, wait.
Isn't it
I know it's D, but I'm like trying to visualize.
Isn't it because for Q1 or Q3 are not like past the median of the other two? So like if her Q1 was past the median of the other two, 75% of her words would be larger.
Oh.
I'm seeing it backwards. I see what you're saying.
I see it now.
Yeah, no, I see what you're saying. 75% of the words in Rawlings distribution are longer.
So if you move the Rawling distribution to the right, then
Correct.
that would be correct.
That's correct.
Okay.
Yep. I know why. I know that I wouldn't select D. I'm trying to explain why. I'm having a hard time explaining why.
I think I got it.
How about just for those of you at home, it's just not,
Yeah.
right? Because we've got D. I mean, D was the better answer. We knew it was D. And on the actual test, once you find that, man, you got an answer you're locked in on, take it and roll, because we really don't have the time on the exam to go through each one and explain to myself, well, I know it's not this one because, and then go into this huge detail of why not, right? A lot of times you see one that is correct, let's rock and roll, okay? I'm doing it right now just for you and for us. We go from there. Kind of wordy. That last one was a little wordy there. Do you want to keep going? Straight ahead?
Yeah.
6?
Yeah.
Ooh, challenges. I like it. Let's go through it then. Number 6 and 7?
Yeah.
That cool? And continue to look forward if you wanted to ask a specific question at all or go through it. We'll look at it here. We're going to go 8 and 9, you think, too? Delete that. 6, 7, and we'll go here for 8, 9. Okay. All right, let's check out 6 and 7 here. See what we've got. It says the density curve. All right, stop right now. What does density curve mean again? A normal distribution is that a density curve?
Yes.
Yes, why?
Although the data is under the curve.
Correct. And we also say that the area under the curve is 1. Okay? That's a density curve. Now, is this a normal curve? Is number 6 a normal curve? No, what makes it a normal curve?
It's, one standard deviation away.
Perfect.
I can't even remember. I think it's 68. Next one is 95, and the next one's 99.7.
Good. We call that what rule? Empirical rule. Good, Julie. So does that make sense? This is what we would be there. Perfect. Yeah. Thank you very much, Trevor. So this would be the empirical rule, right? This is what we're talking about. So when we say the density curve below shows the distribution of a variable that takes values from 0 to 1, okay? What percent of the observations lie between, and really we could just kind of make this, so the area underneath this is 1, right? So from 0 to 0.5, all right, 0 to 0.5. What percent of the observations lie between 0 and 0.5? Thoughts on how we could find that? Trying to find that area, right? You see something here? What do you see?
It's 25, right?
Why do you say that?
Because the box is 50%, and the
Mhm.
two triangles are each 25.
Correct. Correct. Exactly right.
How did you know that the box was 50?
Well, as I look at this, right, this is right here from 50%. If I look at the huge triangle, right, that whole thing is 1.00 or 100%, right? We see that the triangle up above is a mirror image of what I just highlighted below. We then look at the box and recognize that really there's 4 separate triangles that are created here. Since there's 4 separate triangles, that means there's 25% per triangle. And so because it's from 0 to 0.5, we would say that the answer would be B, 25%. Now, does someone have a better way of doing that? I think there's a better way of doing that.
Seems like geometry. Yeah, really.
Yeah.
Statistics.
I know, you just need to know really it's that there's 100% in the density curve, right?
Yeah.
Do we know how high this goes? No, so if I label that as x, 1 times x equals 1.00, right? 1 times x divided by 2. Sorry. Because you have to, it's a triangle, right? Area of a triangle. So 1 times 2 times x, if I multiply this by 2, then x would be equal to 2, right? So this is going to go how high? 2. Okay. However, if this is, got it, this right here is halfway between, right? So if I'm trying to find the area of the blue section, this isn't going to be 2, this is going to be 1, right? So 1 times 1/2 is 1/2, but since it's a triangle, I got to divide it by 2 or divide it by 1, multiply by 1/2, which would be what? 1/4, which is what? 0.25. Now this right here, you don't have to really do that, but if you see it in terms of algebra, if you like an equation, that's how you would do it. If you do better by visualizing, and I mean, you could pretty much visualize, approximate whatever you want to say there, guesstimate, but 25% would be the answer that's there. Okay. Thoughts there? All right, sweetness. Let's go to number 7. I think there's one like this on number 7. See, Trevor. A grade of C or C plus is assigned to a student who scores between 55 and 70. Okay. So here, between here and here, right? Okay. The percentage of students who obtained a grade of C or C plus is what?
20%.
Why?
Did you draw the line over?
Okay, so I draw the line over. This is, again, this is cumulative. Why is that important?
So that if it's 70 is all of the ones below it added together.
So you're telling me that out of those that got a 100, 100% of people got a 100 on the AP stats final? That'd be nice. That'd be really cool.
Take that.
You would take that? I would no, because what does this mean? Cumulative means 100 or anything less than 100. Does that make sense? That's what cumulative means, right? Does that make sense there? So from 60 to 70, the 60th or the percentile of anyone that got 60 or less than 60 was 0.2, right? And from 70, it was, if I went across, would be about 0.5, right? This was 0.5, this was 0.2. So the area or the change in our cumulative frequency from, I want to make sure I got that right, from 55, my fault, should be right here, right? So it should be right above that. So I would say about what, 0.3? Did I get that right? Wow. You just, that was great. All right, 55. Oh, that's because my pen's off. That's why.
Yeah.
All right, so if I go 0.5 right here, right, to 70, or 55 to 70, 55 would be at 0.3, 70 would be at 0.5. Would y'all agree with me on that? It's hard to see from up here. But if I drew that across, that's what I would get. So 0.3 to 0.5, the difference between that would be what? What percentage of people got between that?
20%.
20%. So I would say that would be B right there. All right. Questions on that one? This is good. Okay, let's go to these next few. Blow that up a little bit. And if you got any other ones, just throw them out there. It says a sample was taken of sales of the salaries of 20 employees of a large company. The following are the salaries in thousands of dollars for this year. For convenience, the data are ordered, all right? Suppose each employee in the company receives a $3,000 raise for next year. I love this. I love these ones. And actually, I don't even think we need the numbers, actually, but I could be off on that. I could be wrong. It says if each one had an increase of $3,000, use scenario that's above, the mean salary for the employees will be what?
Increase by $3,000.
Yep, because remember our hands, right? When we move that, add or subtract, that will change that 3,000. So I would say we'd increase it by 3,000. Now, what if I said, what would happen with the standard deviation? It would stay the same, right? Because the variability, the spreading out of the data would remain the same, okay? Just a heads up, this is maybe something you already know. Variability, what is variability? We say that word, but what is that? It's like the spreading out of data. What are some numbers that could be associated with variability? Like when I say variability is not a number, it's just kind of like this has a larger variability than this one, right? But if I was trying to find one number that relates to variability, what would I find? Which would be your range and standard deviation, right? Those are all both referring to variability. Does that make sense? Okay. So yeah, just a heads up on that. So when we go to, let's say, number 9, it says the normal curve below describes the death rates from heart disease per 100,000 people, okay? The mean and standard deviation of this distribution are approximately what? Well, the mean's pretty easy, I think, right? What's the mean? I think, yeah, 190 based upon the answers that they gave, right? It looks really like 200,000, but if they said 190, those are the ones that are closest there. Would 100 be that? No, so we could cancel those out. That always helps me if I have one that I can simply just cancel out. All right, well, there's one down there that kind of was hidden. That was 200, right? So what we can do is come back to that here in just a second and see maybe if that one was the correct one. So before we go to C, D, and E, because 190 is pretty doggone close. That's like right there. It's really hard to tell which one it would be. So let's go to standard deviation. Let's say that this mean was 200, right? Could the standard deviation be, number 1, let's look at C, 65, right? Well, if I added 65, 65 would be like right here, right?
Mhm.
Subtracted 65, it would be right there. If I added another 65, that would be like 320 something, 330, right? So 330 would be like something in there, and it would mirror itself, so it would be something like right in here, right? Did I do that right? Okay, so this would be 90 or 68, 95, and then if I did it again, that would be 20 right here, right there, and like right here. And so this would be like 99.7. That actually looks pretty good, doesn't it?
Mhm.
Okay, let's do the next one, which would be like 100.
It's too big.
Why would it be too big there?
Because by only doing 2 standard deviations, you're already like at 100%.
Yeah, right here, 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 and here, you've already pretty much gotten 100%, right? So especially if it's 190, you'd actually be in the negatives on that over here. And then that's okay, but after 2 standard deviations, it'd be way out there, right? And look right here, the E, really we're between C and E. The standard deviation increases to 130. That's way out there, right?
Can you even have a negative
You
for
can.
this?
Yeah, you can. It's
negative people killed by heart disease.
yes, that's probably not going to happen, right? Your data is probably faulty, right?
Okay.
Your data is faulty, but is it possible to have that? Yeah, absolutely, it is. It's just not accurate. Probably the sample size wasn't large enough, or we weren't, something that's wrong. But you're right. In this context, that wouldn't make any sense, right? It would not make any sense. So I would say the answer would be C. Okay. The tricky part that people will mess up on is they'll say, "Oh, 200 looks like for me." Looks like that's the mean, right? But it's hard to tell. The fact that it's 190 and 200, 100's way off, right? We can eliminate those two, but just be careful on those. Sometimes they try to trick you, right?
We do number 11.
Yeah, absolutely. How are you feeling on these?
Okay.
You okay? All right, number 11. You have another one, y'all? Y'all see it all? 16 I'll do.
Yeah, 16.
Gotcha. That one I did yesterday,
Oh,
and I was having a hard time figuring out where our numbers were. Maybe we could talk this through,
yeah.
okay? Because I was like, what is going on? So in terms of the output, I'll show you where the output is, how to find the equation. The weird thing was the way that it was set up there. So we'll take a look at that one. I did that in yesterday's podcast, and I'll be honest, I got stumped. I was like, I couldn't figure out where the numbers came from. Maybe you all can help me. Let's see, I'm gonna delete these two. Okay, let's put these on here. So I'm gonna do the first one that you had mentioned, which was 11. That was 11 right there. And then this one was the second one, right? Okay, number 11 says, let X denote the time taken for a computer link to be made between the terminal in an executive office and the computer at a remote factory. It is known that X has a normal distribution with a mean of this and a standard deviation of this. On 90% of the occasions, the computer link is made in less than that time, okay? And is made, in less than, and it's trying to find that, right? Okay, it's a really good question. One that we really need to know. It's kind of a big deal on this one. So let's go, first off, the fact that there's a normal approximation, no matter whether it's an FRQ or whether it's one of these, highly recommend drawing a picture. Okay. The mean is what?
15 minutes.
15. What does the 3 represent?
Yeah.
So I would, first off, FRQ especially, write that down. Mean, comma, standard deviation, big N means we're talking normal distribution. So we could put 18 and 12, but if it's a multiple choice, you don't have to worry about that. What are we trying to find? Yeah, so 90%, we don't really give a value. We get 0.90, right? The 90th percent, and is it less than or greater than? Less than this time, right? Okay. So based on that information, we're trying to really find the 90th percentile of this normal distribution. Does that make sense? Okay. Now, normally we go to normal CDF, right? We find the area between two things to find what the, out of the area of one, what is the proportion of that area of one that falls between these two different numbers, right? However, with this, we're almost going backwards. Do you remember what we use on our calculator to go backwards?
Inverse norm.
Inverse norm. Nice. Okay. I think it's right below there. So you would go to inverse norm. And I'm trying to remember what they put first. It's on your calculator. But I believe they put the 0.9 first. So we would say, I don't know what they called it. Is it called? Here, we'll go on here. So just in case, on an FRQ, you don't have to worry about it. Or I'm sorry, FRQ, you worry about it, but on a multiple choice, you don't. So we're going to go second vars. Remember, that's where we live, right? Inverse norm's right below here. So the area goes first. That's right. So area, comma, mean, comma, standard deviation, right? So we put 0.9 in for area. Mean is 15. Was it 15? Is that right? And then the standard deviation was 3. Okay. And we go to the left, right? That's pretty traditional there. And we'd put 18.84, okay? So 18.84 is kind of what we're looking at there. And it should be D, right? So if I was doing on an FRQ, I would put area, comma, mean, comma, standard deviation to establish what I'm doing. Then I could put this back in, right? Another way you could do it is do the z-score equals x minus x bar all over standard deviation, right? The z-score I would find by going to my whatever was 0.90, right? When I go to 0.90, this would be a positive z-score, right? What does z-score mean?
Number of standard deviations.
Great, the number of standard deviations from the mean, right? So it would probably be like a higher z-score, right? I think it'll probably be 1 point something far down there. So we would just make sure we plug in z-score. We'd be solving for x. For x bar, we put 15. For standard deviation, we put 3. So now we wouldn't be solving for my z-score. I'd be solving for my x value. Okay. So that's another way you could do it as well. But either way is fine by me. Okay.
Wait, so you would find like the 0.9 on here?
Correct. What'd you get for 0.9 on that?
I think it's 1.29.
Gotcha. So we would then multiply this by 3, right? 3.77 equals x minus 15. Add 15 to both sides, and I got 18.77 would be that value. That's there. Is that correct?
Close enough.
It's pretty doggone close to D, right? This normally is going to be a little bit off, just because you're approximating almost. But yeah, that's how we would go after that. Okay.
And explain again why you're doing inverse norm and not normal CDF.
Remember, normal CDF is finding the area in terms of a proportion, right? The area underneath the curve is 1. So when I get an area of 0.75, what does that mean? 75% of the data falls between this to this, right? But inverse norm, if I was finding context here, if I was writing context, we're given the percentile of 90% and saying what value goes here. So it's almost the opposite of what we did with normal CDF. So putting this in context, I would say when it's 90% of the occasions, the computer link will be made in less than, or I would say 90% of the occasions this computer link will be made in less than 18.77 seconds, right? That would be the 90th percentile that's there. So you could probably tweak that wording, but that's kind of the idea. So just the opposite of it is what we're looking at. Questions? Okay. Let's go to this one. I need y'all's help on this one. You ready for this? Okay, so first off, here's what I need. or let me remind you of a couple things, okay? All right, when we go here, we ignore. I don't know if you remember this or not. This is a computer output, right? In order to find the equation, we ignore the SE coefficient, right? And the R squared is the variation in Y as it relates to the least squared regression line of X, right? Remember that definition? That's R squared. R is the residual, that'd be the average error, right? We would square root it to find what our average, or what our error would be there, right? Our average error of this. S is standard deviation. Remember, what's standard deviation? Again? Average. Correct. Average distance each value is from the mean. Or in this case, we'd say, because it's a least squared regression line, average distance each dot is from the least squared regression line, right? And then put context with it. Does that make sense? Those are, no, it doesn't?
No, it doesn't.
We're good? We're good?
What's R squared again?
R squared is, and I would go back in the definition because what I'm saying is a ratchet version of that. But what this R squared is something along the lines of whatever this is, 43.26% of the variation in Y, put context of what Y is, okay, is related to the least squared regression line of X, put what the context of X is, okay? And I'll go back through and check in your notes just to be sure so you can get that specific definition that's there, okay? All right, so with that being said, I know this, okay? I know for a fact, based upon this right here, I know that the equation is as follows. Y hat equals the second one that's down below, this calories that's related here, okay? This doesn't even seem like it's the bottom one is always my slope, okay? So we would say 0.067x, and then the top one's my y-intercept, so plus 2.08. That right there is the equation of the least squared regression line. Here's the kicker, okay? This seems almost unrelated to what's on top because it's talking about something with calories or something. Does that make sense? And so that's what's throwing me. I'm thrown off by this because I don't think it's the exact. I don't think they go together, if that makes any sense there. I don't think this output goes with what's on the bottom. But here's the thing. It does say that the number of eggs is given in thousands. So that means when I say 40, this is related to 40,000. Does that make sense? So really, the rise over the run, if let's say this computer output is related to it, I rise 0.067 as I run 1, right? That's the definition of slope. So I rise 0.067 number of eggs in thousands, right, as I run 1 centimeter. So we could say that for this slope, we can expect that as the number of eggs increases by 0.067 in terms of thousands, or you can just put 67 eggs, right? As it increases by 67 eggs, we can expect the run or the increase of the fish length to increase by 1 centimeter. Am I making sense on that? But that still doesn't have anything to do with this down here. And the fact that this is calories right here, we didn't talk about calories in this specific example. So I think that, I just think that it's not related. Does that make sense? Do y'all have a counter to that? I just think it's not related. But does that make sense on how this would be the equation?
Yeah.
How would interpret? How would I interpret 2.08? I know it's not on here, so throw this one out, okay? But 2.08 represents what?
There were 0 eggs. That's how long the fish would be.
Yeah, so if I put 2.08 is the y-intercept, right?
Not 0
Okay.
eggs.
So this would be 0, the point would be 0, 2.08, I'm sorry, 2.08, right? That would be what that point is. So just talk that through. 0 change in X
Fish length.
with the, so my fish length in centimeters, if it was 0, right? We can expect that there were how many eggs? Well, don't do the thousands up here. Don't do that. We'll just say that there were 2.08 whatever context we're talking about, right? Does that make sense on that? Or did I confuse you?
If there's zero. I just think it's
If-
zero.
If we did it in terms of eggs, the reason why is because this isn't related to it.
Okay.
So I just don't want you to get confused. But let's say we were related to eggs. We'd say as the fish length of centimeters was 0, we can expect that there were, if we converted it to thousands, it would be 2,080 eggs, right? That are there. Okay. People say I say eggs weird. That's fine. You can make fun of me. That's fine. But that's how we would interpret the y-intercept. Okay. Robbie, you look confused. Are we good on that? Okay. Big thing is just knowing how to interpret this from a computer table. How do I interpret slope? How do I interpret y-intercept? Y hat means what? Predicted. Good. And really, to be honest, this is not going to give you full credit on a FRQ. Instead of y hat, I do like this. Make sure you put eggs, or for this one, it would be what hat? Eggs hat, right? And you can put number of eggs, that's fine. And X, instead of putting X, put fish length or length or something like that. Okay.
Would you always use the one on like this, going this way to do the predicted, or for the y? Is it always like whatever's on this side of the?
Correct. Y-axis, x-axis.
Okay.
That's why for me, I always put this over 1, and I'll even, on my FRQ, I'll even say, okay, this is the eggs over the centimeters, right? And so I can then just interpret it easy as I increase by 0.067 eggs in thousands, right? And we know that we can expect that the fish length will increase by 1. Okay. All right, are we good on that? Question on the linear regression line. Can we say cause and effect with linear regression line?
No.
What's the right word?
Assume.
Close. Association, right? There's an association between this, right? Remember the football one with the green being offense, the pink being defense? Remember we did that? That was the huge activity of. That doesn't mean if you have a great offensive points per game that you're going to get a lot of wins. But there is an association between that. You see the difference? Okay, awesome. Questions on any? Oh, I got one more, I think, right?
Can we do 18?
Yes. Oh, yeah, I think I already. Perfect. I already did that one. Okay. 18. Let's do. Yes, let's do it there. 18. Is there another one you all want me to get while I'm here? 18. 22. And 23. Okay. Ooh, going to the hard ones, I see. Okay. I will definitely do that, those few. Do we want to do an FRQ as well while we're here?
Sure.
We want to wrap up with some FRQs. If you have more questions on some of the ones below, either message me. I know we'll be at Panera later today from 3 to 5 if y'all want to show up. If not, I understand completely. But I am going to do that. But if you have a couple other ones that you're like, I don't really get, we go through that. I know this, Julie, I think on the podcast yesterday I did this one.
Okay, you don't have to do it.
Is that cool? Go through it. Is it cool if I do another probability one that might be a little tougher?
Yes.
27?
Yeah, 27 or 28.
Okay, 27. Okay, so 28, let me do this real quick as I podcast this, and I'll come back to all those other ones, okay? But I do want to just look at this, just kind of 28. What does this mean when it says find B dash F and write in words? This means the probability of B given that what? F occurred, okay? So just a heads up on that. I can go through that one here in a second, but just a heads up. So you said 27 and 28. We'll do those two. Do they all relate to 5/8? Yeah, they do. Okay. All right, we're going to do that one. And did I get the other one that we were looking at? What one was it again?
22 and 18.
22. Right here. Okay. Let's see if we can maybe just talk through it since I've got it up right now. Let's see. If I need to show work, I will. So a jar contains 60 red marbles and 40 white. Okay, fair. 15 marbles are randomly drawn from the jar without replacement. The dot plot below shows the number of red marbles out of 15 drawn in 200 computer simulations. What does this sound a heck of a lot like?
The,
So what is our population?
200. Wait,
Or actually
100.
all.
Which is how many? What's big N?
Basically like 100.
100, right? Big N is 100 because it's taking it from the 60 and 40, right? What is the sample size?
15.
How many samples are we taking?
200.
So it sounds to me like we are doing a sample of a sample. We call that a what? Sampling distribution. Good. If I said out of 15 and we just did one of them, that would be a sample distribution because I'm taking one sample. So sampling distribution, that's what we should be thinking of. Okay. So it says this, based on the dot plot, is so question, each dot represents what?
One sample.
One sample, and specifically what from that sample?
The number right now.
Good, in that one sample, right? Excellent. So based on this dot plot, which of the following is the best estimate of the probability of drawing 3 or fewer white marbles out of 15 from the jar? Okay. All right, so let's talk about this real quick. 3 or fewer white marbles out of 15. Question, does this approximate a normal distribution? This is a good one. Yeah, let me actually write stuff down on this one. This is I love these ones. These give me such excitement. Yeah, is that you too? Give you all excitement?
Yeah, very much.
Good. Good. You get a little sad?
I can never get these ones.
All right, first off, can it approximate a normal distribution? Say this is an FRQ and we have to talk through that. How do we know?
Gotta do the test.
Got to do the CLT, right? Now, right here, I do not have to show this, but let's just check. N times P, greater than or equal to 10? Is N times 1 minus P greater than or equal to 10, right? So little n is what? 15, right?
15.
What's the probability of selecting a red marble? 0.6, right? 0.6 times 15 is 9. Is 9 greater than or equal to 10? Is that large enough to be able to assume that this is a normal distribution?
No.
No, it's not. Okay. All right. So we just hit a brick wall. What do I do next?
Just right. Come back later.
Question. Okay. Here's a question. The brother of this right here. Okay. Sampling distributions approximating it as normal is a binomial. Okay. Is this, so let's go over bins real quick. Okay. All right. Let's go over bins. Is it binary?
Yes.
Why?
It's either red or not.
Red or not? Is each independent?
No.
Maybe, maybe not. We'll come back to that, right? And success percentage, is that the same? These are like really very similar to each other, right? We have a set number of n that we are selecting. Yes, we do. How do we know that whether we can use this independent and success percentage, whether it's, even though you're right, it's really not independent if I select one like the starburst activity, the reality is that it really does change what I will get on the next one, right? 10% of the population, right? Now, again, all of this stuff you don't have to show, right? I mean, this is stuff that you can just kind of throw down and just say, okay, is it? No, okay? But on the FRQ, you would have to show this, okay? So I would go right here, independent and success percentage is n less than or equal to 1/10 of my population. My population is 100 is 15 less than or equal to 1/10 of 10. So can I assume that? We hit another brick wall. Okay. By the way, I have not done this problem before, so I'm going along with you right now.
Count all dots in 12 and 13 and divide that by 200.
Based on the dot
Can we
plot.
see on the dot plot? There's none 3 or less.
Mhm.
Can we just say 0? We're looking at it.
Based on this dot plot. Well, it probably would be a good idea for me, just being honest with you, that I actually look at the question, because right now I literally am looking at the question, and what does it say?
It's asking for white.
Well, it says based on this dot plot. So probably I did more than we needed to.
Oops.
However, what I did though, it's still. Do you see how that if I were to like have an FRQ, how that would be beneficial? So number one rule is to probably read the question first rather than getting too excited about what type of problem this would be, okay? So it says, based on this dot plot, which of the following, so erase that, which of the following is the best estimate of the probability of drawing 3 or fewer white marbles out of 15? There is no 3, right? So what does that mean? That means in 200 samples, that means we got how many 3s?
But isn't that?
That's
for red.
Where
So
it's
it'd be
asking for
12,
white.
For
13,
white.
and 14.
Okay, so if we select 15, right? Good point. So if we select 15 and it's looking for white, then what are we going to look at on the right side then? Yeah, because if we select 14 reds, that means we have 1 white, right? And I don't think there's a dot there, is there? So would we be looking for 3 or fewer would be what numbers again? It's 3 or fewer, right? So wouldn't it be just 13, 14, 15? No, it'd be 12, 13, 14, 15. Because if I have 12 red, then I'd have 3 whites, right? So we're looking for 12, 13, and 14, okay? So now as I do this, out of the total 200, right? How many were at 12, 13, or 14?
Let's make it bigger.
Yeah, that's probably good, right?
6, 7.
That's 7 right here. 1, 2, 3, 4, 5, 6, and 1. Is that 1 there?
Yeah.
7. So 7 out of 200 is 0.035, which is D.
There it is.
And Coach Jay made that much more complicated than what he should have. Okay. The more I start getting into statistics, the more I realize, like, I get excited about like tough ones. And this was not based on this dot plot. Read the question. That's the big thing. Okay. Now, if they didn't, and they did ask a question like where I was taking it, where it did like the normal approximation, it worked, or the 10% condition worked, you could have either done one of those two. So you could have approximated as a normal curve and then attacked it that way, or you could have done it as the binomial and attacked it that way. Either one of them would have worked. Okay? But neither condition was met. So
Sorry, my viewers.
yeah, live viewers, hopefully you enjoyed that journey as much as I did. Okay. Good stuff. Okay. The other ones, I think I had a couple more, didn't I? Those that are in Sweden appreciated it, I know. Appreciate you. Have we done this one? Was this one 18?
Yeah, we haven't done that yet.
Was 18 one of them?
Yes.
18 says, okay, we choose a random sample of size 3. Okay, fair. Here is the employees of a small company. To do this, we will use the numerical labels attached to the names below. All right, so like one is Betchhofer, I think is how you say it, right? Almost named my daughter that, but it was a close call on that. And so you go from 1 through 9, right? It then says we will use the following list of random digits, reading the list from left to right, starting at the beginning of the list, okay? Big concept, you need to know this. Like huge simulation, how to explain it. Huge concept, okay? For the test and possibly an FRQ, all right? An FRQ. So just study it for the FRQ. All right. This in scenario 4.3, the simple random sample is what? Why?
Because you see 1, and you
Okay.
can't do 1 again because you already picked her.
So 1 represents who? Betchhofer, my daughter. 1 I can't do again, right? I can't do that again, so we ignore it. Then we go to 7,
It's Taylor.
and then 9.
Is
Weiss, with S. Yes, that's exactly right. Okay. Questions on that one? Do you have any questions on how to do like a simulation with this?
Can we do it?
Yeah, I'm not very good at explaining them on like explaining how to do it.
Yes. Could I see if there's an FRQ on there? If so, we'll go right straight into the FRQ that is here. See if there's one. By the way, this was the AP exam from last year. Isn't that beautiful? It's beautiful. There's not one here. There was one from the other day, though, right? I'm going to just use that example. Is that cool? Yeah. So let's pretend that we have 60 within our 60 districts, if you remember. The one way that I love to do this is before I actually write out, I draw the diagram. Because if I can draw the diagram, then it helps me to visualize, hey, what am I actually doing here? Always, this is the couple keys. Number one, randomize, right? I can't make it an observation, like I can't have a good observation or an experiment unless there's some sort of randomization that's involved, okay? Unless I'm blocking. If I'm blocking, then what I'm saying is that, okay, this might be the reason and not what I'm trying to observe or what I'm trying to do it this way. Before I do it, let me go for it, okay? Let me just say it this way. We have 60 and we're trying to go two ways. We want to have 30 and 30 on each side, right? Okay, this would be group one, whatever group one means, and this is going to be group two. The way you put them into groups is very important. Some people said, hey, why don't you just say, hey, you're in here, you're in here, you're in here, you're in here. How do I know that there's not bias that's involved in that, right? Oh, I like yours. Why don't you go into this one? Oh, you want to do it this way? Why don't you go to this one? So you can't at the end really then say that the change was associated to by chance, right? Or because of what you're trying to do. For instance, the monetary and not monetary reward that was given out, right? It's important to be able to compare those two, but I can't compare unless I first randomize those 30, okay? So we randomize those 30 by saying, okay, and I'm going to put randomize here. Randomize, right? Okay. If I were to block this, a blocking option would be before I randomize, let's put the 30 that are in maybe the north, right? And 30 that are in the south. I mean, the block could be anything. But we could put those 30. Then after that, right, I wouldn't randomize here, but to get to the next category, 15 would go one way, 15 would go another through randomization, and then same thing here and here. So even though randomization was involved in the first step, eventually it will be. Does that make sense? Does that make sense on a block? Yeah. A block is associated to an experiment. Got me? If it's an observation, observation is stratified. Y'all follow me? That's like the same thing. So an observation is if I'm just simply observing something, okay? A experiment is if I am trying to, what's the right word? Y'all probably know better than I do. Yes, I'm manipulating something, right? I'm manipulating a variable, right? So that would be the difference there. So this would be I'm manipulating, right? Some of them, half of them, 30 of them, right? In this context, are getting a monetary reward, and then these 30 are going to get not monetary reward, like a vacation or something, for being successful in their business or whatever, right? So do you see the difference there? I know I'm going through a lot of stuff. Before you leave over there on that side, all of that, the population stratified cluster, that's observational. And then experimental would be like block, multi-stage block design, right? Or I'm sorry, no, multi-pair design. Did I say that word right?
Match pair.
Match pair design, thank you. Match pair design is where we order them, right? From 1 through 60, the first two, we pair them together. One person we randomly select goes in group 1 and one goes in group 2, right? And we do that all the way through till 60. So does that help you so far? Just kind of talking over it. So once I do these randomly into these 30, before I randomly select, I've got to explain how did I randomly assign them, okay? And in order to do that, you could even put how, question mark, because you've got to explain how did I do that. Well, if I number them from 0, 1 to 60, okay, and I would say that I number the districts from 0, 1 through 60. I then go use a random digit table and ignoring any repeats or numbers that are outside of my range, okay? Once I go through, I select the first 30 random numbers. And once I do that, I put those first 30 random numbers into group 1. The remaining 30 that I did not select go into group 2, right? And when I say group 1 and group 2, talk to me about that. What is group 1? And it could be whatever you want. Not monetary, and then the other 30 is monetary, right? So I would make sure I randomly select it, okay? Once I randomly select it, I say over the course of time, or it could be a year or whatever the problem says, right? What do I do after that time? Maybe I compare the change, right? Compare changes. Sometimes we compare the means of the organization, compare the change in means of from the year before and what it is after the group 1. And then once I compare those changes from group 1 and group 2, what do I do at the very end?
Compare the 2 groups.
Yeah, I compare the groups, okay? Now, are there any lurking variables that were in this that could affect the actual comparison overall? Probably, right? Probably. Can we eliminate all lurking variables? No, but we can help with it. Let's say the big one was, and we talked about this in class, the big lurking variable was, well, let's say that group 1 was higher than group 2. However, the majority of the larger districts that had more money from the previous year were the ones that were in group 1. That could have affected it, not because of the monetary reward, but because of the fact that they're just larger districts. So what could we do to kind of counter that? We can block it, right? So we can say, whatever the block is, right? Maybe the South has higher ones than the North, so South and North, right? Or we can go into the word that you said, and I'm match pair, right? And then we compare them together and randomly assign it based on that, right? One goes in one goes in the other.
No.
Now, I went through a lot of stuff. Does that?
On a matched pair, do you have to randomly assign the people their numbers, or can you kind of treat it like a block? Like, say if you said the problem we had was, the last year they had more money, could you line
Yes.
them up and people that had most money to the least money and then pair them?
Yes, that's how you would do it.
Okay.
Now, after I pair those together, just like a block design, when I actually do the blocking, that is not random, right?
Mm-hmm.
When I block, it's because I'm blocking for a reason, guys and girls, right? I mean, whatever the block is, right? But after I block, there's always some sort of randomization that's involved. Once I block, then I randomly assign within those blocks. It's almost like I got too many experiments, right? Where I then have half go one way, 15 go one way, 15 go another. Same thing up here, right? So you're actually going to be comparing within each block. And then once I compare in each block, then after that, then I can make some conclusions possibly about, hey, what am I observing, right? Here's a question with observation, can I have cause and effect? No. An experiment, can I have cause and effect?
Yes.
Yes, I can. Yes, I absolutely can, right? And the word is statistically significant, right? Is it statistically significant? You don't know all of the details about that. You don't have to, but that's a good word to use on an FRQ, just a heads up, okay? And statistically significant is allows us to infer that something happened. We call that the Holy Grail. That's what we've been talking about, okay? All right, that's a lot of explanation on that. I hope that helped, Julie.
Yeah, that's good.
Cool. All right, let's go to, I think there's one more problem, right? And then I think we might wrap up with that. That doesn't mean I'll go anywhere, but that just means I'll stop the podcast. There was one more that I thought I was checking out. Wasn't there? It's like a probability one or something.
Yeah.
I think it was that one. Was it this one? 5-8?
I think so, yeah.
This one here. Here and here. 27 and 28. All right, let's check this out. Okay, this one's pretty good. One of the things with a tree diagram that anytime we have probability, it just helps us to see it, right? So this is the student that's a male, student that's a female, okay? 0.8 is the student that's a male. If they are a male, then 0.8 means that it's the student that ate breakfast that morning. So if I say, what is the probability that they are male and they are a student, and they eat breakfast, sorry, and the student, how did I get that? But I would multiply that together to get what? 0.32, right? Are these things independent of each other?
Like the male and the female? Or-
No, the fact that if you're male, you eat breakfast. Can we solve that? Independence says that the probability of eating breakfast is equal to the probability of eating breakfast given that you are a male. Isn't that right? Because think about it, independence means that one thing is not affected by another, right? So let's try it out. We're going to test it out here, okay? If you are male and you do not eat breakfast, that's 0.4 times 0.12, that'd be 0.16, right? 0.6 times 0.3 for females would be 0.18. And all of these should add up to be equal to what? 1 if you multiply correctly, okay? Now the question is what is the probability that you will eat breakfast? 0.18 plus 0.32, which would be 0.50. Is that equal to the probability of eating breakfast given that you are a male? Well, given that you are a male means that we are focused on just this side, right? So what is the probability you will eat breakfast given that you are a male? Say again? Be careful. This is the probability that you are male and you eat breakfast.
Oh,
Given that you are a male, the probability is either 0.8 or 0.2 depending on whether you eat or don't eat, right? So are these events independent of each other? No, they are dependent, right? The fact that you are male, does have does impact whether you eat breakfast or not. Okay? Am I making sense on that? That's a tough concept. I go into a lot of detail on the podcast yesterday with that. This is also something that you can look at too. Okay? So check that out. That podcast, I think, does a pretty good job. We spent like 15 minutes on that. Okay, so with that being said, I didn't want to erase that. Sorry. It says this. In scenario 5.8, given that a student who ate breakfast is selected, what is the probability that he is a male? All right. So, given that breakfast was eaten, right? What's the overall for breakfast eaten? We said that already. 0.3, 0.5, right? So 0.5 is all breakfast, right? Okay. Given that they ate breakfast there, what is the probability that they are male? Tell you what, I don't like how I see that there. I'm going to do it a different way. Is that cool? What's the formula? We remember that the given formula is this, right? What is the probability? We're talking male and breakfast, right? So the probability of breakfast and male, and equals the probability of B times the probability of B given that AM occurred. Isn't that the same thing? Or did I switch those around? Given that a student who eats breakfast, what is the probability that he is male? Actually, it's flip-flopped. Does that make sense? So it should be the probability of male and breakfast equals the probability of male times the probability of male given that breakfast occurred. You see the difference between this one and up here? Got me?
Yeah.
You see that? This is straight from your formula sheet, okay? So I'm really looking for this right here, okay? That's really what we're looking for. So I can do that by taking, what is the probability of males and breakfast? 0.32. And I can divide that by, because these are multiplied, what is the probability that we have a male here? 0.4, right? So we could divide this, right? 0.32 divided by 0.4, which equals 0.8, right? Should be E. That should be my answer. What's up, Jerry? Does that make sense? Okay. So that's how we would find that there. Sometimes I like formulas, sometimes I like visuals, right? If I ever get the given part, which is what we did in 27, if I ever hear the given, I usually go to the formula because it's hard for me to visualize this to say, oh, I divide this over this. Some of you may be able to do it and understand what's going on. For me, it's hard for me to visualize it. So when I go to this formula, just make sure that it's this one, not the one on top. And if you do that, you'll be fine. Okay? Questions on that? And really, to be honest, is that the same as right here? Given that a student is male, given that he ate breakfast, I don't want to get into that. But do you see where I came from there? Okay, awesome.
Why wouldn't we do the total 0.5 divided by 0.32?
Wouldn't be 0.32 divided by 0.5.
Yeah, sorry. 0.32.
Because that's 0.64 and that's what D is.
What's the right answer? Is it really?
I think so.
Yeah, I thought it was like, given that breakfast is served, which is 0.5, so that's on the bottom.
It is 0.64.
It is 0.64?
It's like given that breakfast was served, which is 0.5, which is on the bottom of the division thing. What's the probability that he was male and ate breakfast? And that decimal was 0.32.
0.32 of the 0.5 are male. So that's why.
So we were headed on the right track. You were saying, so the probability that they ate breakfast was 0.5, right?
And of that 0.5, 0.32 were male.
Out of that 0.5, 0.32 were male.
And that's
So this
0.64.
0.64. I would have missed this one, y'all. I would have missed this one. Did I do that formula wrong? Because this should work. You know what I mean?
Mhm.
Unless did I flip-flop what I, given that a student who ate breakfast is selected, what is the probability that he is male? Male and breakfast is 0.32. The probability that they are a male is I see where y'all are coming from. Mine should be the same thing. You know what I mean? If I'm using the formula right, it should be the same thing. That's what's frustrating me. I know why. Dadgum, you coach. It's probability of male times the probability of this one right here was wrong. Because it's the probability of breakfast times the probability of male given that what breakfast occurred.
Oh, that is right.
Does that make sense? I flip-flopped it. You have the formula sheet, so you'll be fine on that. But this right here, if I have the probability of B, I can't find the probability of B again. Does that make sense? So it should be the one that's up here. That means this right here is 0.32 still, okay? Let me do this. Let me freeze this thing. So this is 0.32 equals probability that we had breakfast is 0.5. Watch this. Right here, we're trying to solve for the probability of male, right? Probability of male given that breakfast was eaten, right? We divide by 0.5 because we're trying to solve for this. 0.32 divided by 0.5. We got it. So what I did was, just a heads up, when you go to the formula, just double, triple check. I was going off memory. But when I did this, the key was both would work, okay? And that's what I was saying. If you can visualize that, great. For me, I struggle with that a little bit. I'll just be honest. That's just something. So I go straight to the formula if I hear given. Both would work there. And that's where I was messing up at. So right here, it was everything to do with my formula, but the process was right. Okay. Questions on that? No good? Okay. Let's see what it says on the next one. It says find probability of breakfast given that that we're female. Probability of breakfast given that there is a female there. Okay. So if we have breakfast, right, that is a given, right? So what would we do on this one? I think I just erased that, but 0.18, right?
Mhm.
This is 0.42. Up on top was 0.08. And this is 0.32. Okay. What are you thinking?
It's just 0.3.
What was it?
Just 0.3.
Why?
Because we've already selected just the female part, which we're only focusing on what comes off of F. And the 8% of females that have breakfast is 0.3.
Correct. Correct. That was a little easier because the opposite one went backwards, right? So and maybe the other one was easy for you too. But does that make sense? If it's a female, we're crossed out. Now we're focused on if that's given, everything else up here is gone. Now we're saying if this is true, what is the probability that breakfast was eaten? It would be 0.3.
D.
So it would be D because both are 0.3, but the probability that the student ate breakfast given that she is a female would be D.
Yeah.
Great job. Yeah, that'd be exactly right. Okay, and if you struggled on that, you could always go to the formula, right? Always go to the formula. Just write down the formula, right? That's all I would say. All right. Very good. Remember too, and this is something for all of us to remember, perfection is not the goal on this exam. I mean, we want to do the best we can on that, but the way that it's graded on the AP exam, we want to make sure we get the most points possible. So just be sure you read because a lot of times the questions are meant to trick you. So you want to make sure, just be careful on those. Read them like the dot plot one, okay? So on and so forth, all right? That's why I got you all here because if I did it by myself, I'd be messing up. And go from there. Any other questions that y'all had? I think I'm going to stop the podcast at least. I appreciate that y'all kind of hanging with me today. It's a pretty good length of a podcast. And appreciate y'all. And have a great day. And if you can, make sure you go by your local grocery store because today's class was sponsored by Voss. Get some crystal clear, very crystal clear. All right. Taken out of my backyard creek. All right. Have a great day. We will see y'all. Bye.